All right, before we move on, let's talk a little bit about transition metal ions. So remember what we learned about in the beginning of the class, the transition metals are generally going to be cations. They're going to have positive charge, or they're going to lose electrons. And remember that this charge is variable, so they can have a different or numbers of different charges. So the trick with transition metal ions is that we want to remove the highest N electrons first. So for example, something like vanadium, if you give its electron configuration, vanadium is right over here. So it's going to be like argon, and then 4s2, 3d3. So even though the 3d3 part is to the right of the 4s2, the 4 is a bigger number than a 3. So this is the highest N right there. And so if you're thinking about something like vanadium 2 plus, you're going to lose those 2 electrons. So it'll be just like argon and then 3d3. No 4s electrons. So remove those s electrons first. And this has been shown to happen experimentally. So let's take a look at kind of how we can prove this experimentally. And that's through the difference between paramagnetism and diamagnetism. So a material can be paramagnetic or diamagnetic. So paramagnetic means that it's attracted to magnetic fields. And diamagnetic means that it's repelled by magnetic fields, although to a much smaller extent. So we'll just say kind of here, slightly repelled by magnetic fields. So we're talking about being attracted or repelled by a magnetic field. What we're talking about is spins of electrons and whether something has a spin or doesn't have a spin. And so paramagnetic materials basically have at least one unpaired electron. Right, so they have an unpaired electron, while diamagnetic materials do not. And so the 2 spins cancel each other out. So no unpaired electrons. Everything is paired up. So if you think about silver, right, be careful, silver is an exception. If you think about the electron configuration for silver, it's down here. It's going to be 4s1, 5s1, 4d10. And then if you think about these s and these d electrons, remember they're really close in energy. So some weird stuff happens. But if you draw an orbital diagram for this, you can see that we do have an unpaired electron right here. And so this material overall is paramagnetic. You just need one unpaired electron to be paramagnetic. And then if you take a look at silver plus, remember, you're going to lose the highest N electron first. So you're going to lose this 5s1 electron. So it's just going to be 4d10. And then if you think about the electron configuration there, this one has all paired electrons. So this will be diamagnetic. So that's pretty much it. So know the difference between paramagnetic and diamagnetic, be able to identify when something's paramagnetic or diamagnetic, and then know that transition metals lose their s electrons first before they lose the d electrons. If you have higher charge metals, then after all the s electrons are gone, you'll start pulling away the d electrons.